The median home price in Phoenix, Arizona for the years 2005 through 2009 is given in the table. And so we see this data with the year 2005, 6, 7, 8, and 9, and the median home price is in thousands of dollars. And we're first adjusted the data, and so they're saying let T be the years since 2000. So since T is the years since 2000, 2005 is 5 years since 2000. And so we see that we now adjust that T value to 5. Okay, and they did that with the rest of the data. So notice the home prices have not changed at all. The only thing that's changed is 2005 has gone to 5, and 2006 to 6, etc. So here is a scatter plot of that data, along with the quadratic model and the graph of the model. So quadratic for the model, a quadratic model for the data is m is equal to negative 17.36 t squared plus 224.9 t minus 486.1, where t is the year since 2000 and m is the median home price in Phoenix, Arizona in thousands of dollars. And so here's the graph of the model and the data. And so notice that the data increased and then decreased, and so a quadratic model is reasonable, and so we found a quadratic model, and we've drawn it along with the data. We're asked to first find the vertex for the model. Alright, so we have the model. Then the t coordinate of the vertex is negative, and the b coefficient 224.9 over twice the a coefficient, negative 17.36. And so going through this calculation, we'd have negative 224.9, and we're dividing that by 2 times negative 17.36, and we get about 6.48 to 2 decimal places. Alright, let's find the m coordinate of the vertex through substitution. So I'd have negative 17.36 by 6.48 square plus 224.9 by 6.48 minus 486.1. And I'll go through that calculation on my calculator. All right, and I get approximately 242.30, again to 2 decimal places. So then my vertex is 6.48, 242.30. And so that should be near the highest point on the curve. Now in part B, we're asked to compare the vertex determined from the model with the real data in the previous table. Alright, so here's our table again. The vertex that we found was 6.48, 242.30. So if we look between the 6 and the 7, alright, if we look between those data points, we had 250 and 236. That looks reasonable. Okay, it's close to, so the vertex that we're given by the model is close to the actual maximum median home price, which was 250,000. So I would say that the vertex determined from the model is reasonably close to the actual highest median home price. In Phoenix, Arizona. Is the vertex value of the model a maximum or a minimum? The value is a maximum since the parabola opens down. Exercise D asks us to find the vertical intercept for the model. And does it make sense in regard to the median home price in Phoenix? Does model breakdown happen? Explain. Alright, so to find the vertical intercept, we let the horizontal variable equal 0. Alright, so we'll let t equal 0. If we let t equal 0, then we would have m equals negative 17.36 by 0 squared plus 224.9 times 0 minus 486.1. Alright, so notice that that wipes out the first two terms, and we'd have the m value is negative 486.1, and so we'd have an ordered pair 0, negative 486.1. Alright, so what does this mean? 0, well, remember, if t equals 0, and t, recall, was the year since 2000. So what this is saying is that in 2000, the median home price was negative $486.1 thousand. That doesn't make sense. So this is an example of model breakdown. Right? It just doesn't make sense when t equals 0. Find the horizontal intercepts for the model, and do they make sense? Does this give us a model breakdown? Alright, so let's see. To find the horizontal intercepts, we let the vertical component equal 0. So we will let m equal 0. So then we would have 0 is negative 17.36 t squared plus 224.9 t minus 486.1. Alright, so we have a quadratic equation. It's already in that standard form, so I'm going to use the quadratic formula. Alright, so then t would equal negative, substituting for b, plus or minus square root b squared minus 4 by substituting for a, substituting for c, over 2 times substituting for a. Alright, simplifying gives me negative 224.9 plus or minus the square root, and simplifying under the radical, let's see, on my calculator, 224.9 square minus 4 by negative 17.36 by negative 486.1 gives me, under the radical, 16825.226, and 2 times negative 17.36 is negative 34.9 34.72. All right, I'm going to go ahead and approximate that radical. So the square root of 16825.226 is approximately 129.712. So t is approximately negative 224.9 plus or minus 129.712 over negative 34.72. Again, we break that up into its two components. And we calculate each of those values. All right, so the first one, negative 224.9 subtract 129.712, and divide that whole thing by negative 34.72, gives me 10.21. And the other one, with the addition rather than the subtraction, gives me about 2.74. Now, putting that all together, our horizontal intercepts are 2.74, 0, and 10.21, 0. All right, so what is this telling us? Remember, these ordered pairs represent a time in years since 2000 and a median home price. So this is saying in late 2002 and early 2010, the median home price in Phoenix, Arizona was $0. That sounds pretty good, doesn't it? But it's not reasonable. The house price, the median home price, would not have been $0. It just doesn't make sense. All right, so again, this is model breakdown.